Hey, you made it! This is video 2 of the Rocket League botting tutorial, where we'll start writing code for our BoostHog bot. If you missed video 1, where I explained what we're doing here and how to get set up with RLBot, the link to the playlist is in the description. I'm Ben, and this is Learn Code by Gaming. So in this video, our objectives are really simple and clear. We're going to, number 1, figure out where the boosts are located on the field, and number 2, we're going to tell our car to drive to the nearest boost on the field. Conceptually, that's about as simple as you can get for a boost stealing bot. You just find the nearest boost and go to it. But in the pursuit of those goals, we're going to do a couple other things too. The first thing I want to do is add some additional debugging to the game screen. That will help us inspect what's going on inside the game data without having to print anything out to console and without having to set up the VS Code debugger to work with the RLBot launcher. I also want to simplify the main game loop and pull out a lot of that code into its own functions. That will help us stay more organized and make our code more flexible. You'll see what I mean when we get there. So let's get started by digging into the data.
Alright, so I've finished updating my appearance configuration so that my bot is looking sweet. And now let's go over and open up the botting file. Let's start with the code. So again, the first thing we want to do here is get the boost locations from the GameTickPacket information. And the easiest way to figure out what it is we're working with is to go back over to the wiki for RLBot, and then go to the input and output data page. And if you scroll down to the GameTickPacket, they have a sample packet here for you. So we can look at this and see everything that's contained in there about the current state of the game. And as I'm looking through here, I see they've got information about all the cars in the game. For the game boost, it only tells us if the boost is active and what the timer is on it, if that boost has been taken and it's trying to respawn. It also tells us about the game ball location. And then it has some basic information about the game. It looks like it's mostly time related, and then also the teams. So we saw that the GameTickPacket did have a little information about the boosts, but it didn't have the information we need, which is the location of those boosts. So let's keep scrolling down on this page. It's got information about the controller state. So that's that controller information that we return from our, what's the name of that function? From getOutput, it needs to return a simple controller state. What that needs to look like is described right here. So here's a sample. You see we set the throttle, the steer, pitch, yaw, roll, jump, boost, handbrake, and items for the rumble mode. And if we keep scrolling, there's more information about the field info. It says some values are constant, and those constants are kept in the field info. So one of those things is going to be the boost pads. This is going to have the location for all the boosts. And the reason they put this in the game info instead of the main GameTickPacket is that these constants don't change throughout the game. So they don't want to have to constantly update those like they do with the tick packets. So looking at the field info here, they've got the boost information we need. There's also the number of boosts and the goals. So this will be the location of the goals on the field. And if we scroll down a little further, you can see they even have an example for us about how to get the field info right here. And then they're even showing us how to loop through all the boost pads and find them. So now inside our bot code, let's take a look at the packet to make sure it contains what we think it should contain. So I'm going to go down to the end of the getOutput function here. This will run once per tick. And I'm just going to print to the console something out of that packet. So the name of the variable is packet. Inside there, let's look at that documentation again. Let's check out the game info. Let's check out the game time remaining. So inside the packet there's that game info and then the game time remaining. Let's just print that out to the console and see if that is working. So we expect it to show up here in the console window, but I'll have to start a match first. So I ended up creating a match here between 2 of my BoostHog bots, and that way they don't just immediately hit the ball into the goal. So in here we can see the game time ticking down. It's at 4 minutes 50 seconds right now. And if we switch over to the console window, you can see here all of the current game times are being printed out. And there's quite a bit here because it's doing it 60 times a second. But if we wait and see, wait for the game to start after that goal is scored, we should see these the game time start to go down again once it's running. There we go, it's at 282, 281, 280. So there we've confirmed that we are printing out the time left in the game by looking at that variable inside the packet. The next thing I'd like to do is, instead of printing this out to the console, it'd be cool to put it in the game itself. Now we're already drawing this action display. Down here in Draw Debug, we can see that we're drawing that string right next to the car location. And I find it kind of hard to read there, so what I'd rather have instead is, inside the game window, I'd like an area down here in the lower left just to be able to print out some text. That way we can use this over and over again while we're developing to look into different variables and make sure things are the way that we think they should be. So to do that, I'm going to go back to where I have my print statement here. We're going to get rid of that, and I'm going to create a new variable here that's just going to hold a string that we want to print out in the corner. So call this corner debug for our string. Say time remaining. And then we're going to pass in an integer here. And it's going to do this string formatting for us. Actually, the more modern way to do this, I guess, is using string.format, right? Let's do it that way. And then we just want that same info we were looking at before. I'm also going to put a new line here. So the \n creates a new line, so it's like hitting enter on your keyboard. So that way in the future I can have multiple lines all here, not running on a single line. So now that we have this corner debug string in our variable, we're going to need to pass that to the draw debug function. Then we need to go down to our draw debug function definition and add that as a new parameter. And now we need to actually draw it. So we can see down here in draw debug that there's already an example of how to draw a string in 3 dimensions next to our car. And I bet you there's a 2-dimensional draw string as well. Let's go look for that in the documentation. So I'm back in the wiki. I bet it's under rendering. And sure enough, there is a drawString 2D, and we just need to give it the x, the y, some scaling, the text that we want printed, and what color we want it to be printed at. Let's go back to the code. We're going to print the corner debug string. We got this renderer object, and we're going to call drawString 2D on it. We need the x and the y, so x is going to be pretty close to 0, maybe 10 will be just off from the side of the screen. And then the y will depend on how tall your game window is. If you want it down in the lower left, I guess we can start it with it in the upper left. So because the 0, 0 xy coordinate is the upper left of the game screen, so 10, 10 will be somewhere just offset from the upper left. For the scaling, we just want it at 100% scaled. The text that we want to display, that's the corner debug string. And then the color, I think white is probably the easiest to see. So save that, and let's give it a try. So now we're seeing in the game, in the upper left, there's that time remaining string, and you can see it counting down as that state variable is changing within the GameTickPacket. And one thing to note here is that game time remaining is actually being drawn twice right now, once for each one of our bots that we're running. So if you only want to draw it once, only have one of your BoostHog bots running, or you can add some logic to your code to make sure it's only drawing that output for the first of your bots. Okay, I went ahead and updated our corner debug display just a little bit so that we can draw it in the lower left-hand corner. I found that 900 pixels down was a good number. It puts it in a place on the screen where it's pretty visible. But as we add more lines of text to our debug output, it eventually would go off screen. So what I'd like to happen instead is for it to move upwards depending on how many lines there are in our debug output. So what I'm doing here is I'm subtracting 20 from 900 pixels, which is the initial location, for every extra line that we have in our debug output code. So that'll keep it kind of tied. The lower left-hand corner of the text will be tied to this, or anchored to this position that we want in the lower left-hand corner of the game screen. I also added this if statement here just so that corner debug could be null if we wanted it to be. And I can actually make this an optional parameter just by giving a default of none. That helps indicates that this is an optional parameter for this function. So let's go ahead and test this out, make sure we're seeing what we want to see. I'll just leave one BoostHog in there for this test. And there we see the time remaining now in the lower left-hand corner there. And if we add more text to that debug output, corner debug, going to add to that string other text. I believe if we just save it, it should update while the game is running, and there you can see inside the game other text in the lower left-hand corner. Okay, so now we're confident from our debug output that the game packet is structured how the documentation says it is. The next thing we want to look at is probably that field info, make sure that data looks like it does in the documentation. So in the documentation, I went back to that input and output data screen. And I'm going down to the field info. And I'll grab this example for grabbing the field info. It looks like it's just attached to the our bot, so it's part of base agent somehow. So first we'll create that variable to grab the field info. And then let's go ahead and print it out. Say first boost location. So we're looking at the info. Peek at the documentation again. It should be in boost pads, and then that's an array, so we'll grab the first one and then the dot location. So info.boostpads, that's a list. We want the first item from the list, so do that with the square brackets and the 0, and then location. So if we go back to our game, you can see we can open it up, and without the game even running, it'll still update right away. The first boost location is at location x0. It's got a pretty big negative y value, and then z is 0 as well. So when you're looking at these vector coordinates, I found that the 0, 0, 0 location is the center of the field, right where the ball is during kickoff. And it might even be a good idea to look at the second boost location as well. Just to make sure it's not the same as the first boost location. Look at the game, and now we see the second boost location there as well, and it does have a different x coordinate value than the first one. So everything is looking how we expect right now. So let's go ahead and write our code for finding the nearest boost. I like to start with the function definition first, and that will help me to be informed on what that function definition should look like. So we'll save it to a variable, nearest boost. Get nearest boost will be what I decide to name this function. And it's definitely going to need the info to get the boost locations. I also want to give it the GameTickPacket, and this will help us to find out which boosts are active. That way we don't go and try to pick up a boost that doesn't exist anymore. And then I also want to give it the car location, because we'll need that info to help determine which boost is actually closest. So I believe car location, yeah. And then once we have the nearest boost, we can go ahead and print that out. So the nearest boost will simply be the nearest boost. And do I want to return the location, or do I want to return the entire boost? I think I'm going to end up returning just a location, so let's reflect that in our variable name. Call this nearest boost, LOC for location. And now we need to create this function. So go down here to our helper function area. just write def and then of course the colon, and that's how you create this function. It'll take these 3 parameters that we're passing in. And then let's create a variable to hold the nearest boost that we found so far. So nearest boost location, start with none, and then ultimately we're going to want to return that nearest boost location. And in the middle here, we're going to want to loop over all of the boosts in the field info. So we can do for boost in info.boostPads. So again, peeking at the documentation, this is our info variable. And then if we're looking at just the boost pads, this is going to be a list. And so we're just looping over that list. And then inside, we're going to look at the locations. So we're going to loop over all the boosts. And we're only interested in the large boosts that appear in the corners and the sides of the field. So only want large boosts. So if boost dot, what did they call that? Is full boost. So these are the major boosts that give you 100% boost in the game. And usually if you're boost stealing, these are the boosts that you're taking. So we'll only look at those ones. And if we don't yet have a nearest boost location, we'll just set that as the nearest one. So if not nearest boost location set yet, this will be on the first iteration of the loop. Nearest boost, we'll set that equal to the boost we're currently at. But we just want the location of it. Otherwise, what we just want to set the nearest boost location if the current boost is closer than the currently saved one. So if this boost is closer, save that. So we're going to be comparing the car location to the current nearest boost, and the car location, the distance between that and the boost that we're looking at. So if car location dot, there's a distance function. If we look at the vector class, this dist returns the distance between this vector and another vector. So the car location is one of those vector3 objects, and we need another vector3 object to compare it to, and that's going to be the boost location. And so if that distance is less than the car location distance to the currently saved boost, then we're going to update the boost location with the new one. And we need to wrap this one in the vector3 object as well. Okay, so we've almost got it. The only thing we've forgotten is, so we don't want to pick up boosts that have already been taken. Otherwise, our bot will just immediately go to the closest boost and it'll just circle around that one forever. So in addition to checking that it's a full boost, we also want to check and packet dot game boosts is what it was called in there. And we want the current boost. We're going to need to, I believe those lists line up. They match up in the packet and in the field info. So to get that, I need to wrap this in enumerate. That'll let us keep track of the index for each time through the loop. That way we can grab the corresponding boost out of the GameTickPacket. And I believe it was called isActive. Let me check the documentation for that. Yeah, so what we're doing is we're looking at the packet. Inside there, we're looking at the game boosts. We're going through this list and just grabbing the one that matches up to the one we're doing in the current iteration of the for loop. And then we're looking at the isActive value. And we only want the ones that are true. So we only want large boosts that haven't been taken. So that should be all there is to it. This should loop through all the boosts in the field, looking at only the full ones and the ones that haven't been taken yet, and it should give us the closest one to our car's location. So heading back up to our getOutput function. Remember, we're saving this nearest boost location to a variable, and right now all we're doing is printing it to the corner. So let's look at the code and see if we have something. Okay, so it's saying from where our car currently is, the nearest boost location is this one at -3,000 something, y -4,000 something, and that seems like a reasonable answer to me. But the only way we can be sure that that is actually a boost location is why don't we just have our bot drive over to that location. So I'm going to go back up to our getOutput function. I'm going to move the location of where I call our boost lookup function. I'm going to put it right above where it says car to ball. I'm actually going to comment out that line. Instead of doing car to ball, let's call it car to target. And we should just be able to take our nearest boost location and then subtract our car location. And then we can use that when we use our find correction to decide if we're going to turn left or right. Instead of going to car to ball, let's go car to target. And then in the future, we can actually use this as well if we want to change it to go back to the ball again. All right, so let's give that a shot and see if it's working. We should just be able to resume, I believe. Nope, I must have. So when you're not seeing any output there and your bot just stops running, that means you have an error. Go look over here at the console. So the console is telling me I can't subtract the vector 3 from a VEC3. So we know that nearest boost location, I believe that is just a vector 3, not a VEC3. I think we can just cast these locations. But I believe that would work. Let's see if that took care of our error. Yeah, it looks like it reloaded there correctly. But instead of putting it there, why don't we just have this get nearest boost return one of those VEC3s? What if it's none? Then we'll throw up another error. So if nearest boost location else none, that'll take care of that potential error. Go back up and look at our code again. So we're going to the nearest boost location and using that to find our target. All right. Console still looks good. Let's see what our bot does. All right, it seems to be grabbing that boost, but of course it's not actually picking it up because our bot is already full up on boost, so it can't grab it. It's constantly trying to pick it up, but it can't because it's already full. So to solve that problem, we just need to tell our bot to boost all the time. So I can go to our controller state, self.controller state, and there's a boost property on it. I think we just set that to true, and that should make our bot boost. And sure enough, now it's actually using the boost. Looks like it's having trouble here trying to actually get to that boost. It can't turn quite sharp enough. Alright, so just to make sure it is actually going to the boost like we think it should be, I'm just going to start a new match. So I'll stop that one, start it up again. Let's see what happens. And there we can see our BoostHog is going to all the boosts, just like we want. It's just making a big circle because, of course, when it picks up this boost, the next nearest boost is going to be this one over here in this corner. And so it just ends up driving this big circle around the whole field, grabbing all the boosts. So one issue I noticed is that it's still drawing that line from the car to the ball, and it'd be nice if it could draw it to the boost it was targeting instead of the ball. So let's go ahead and do that. In our draw debug code, it's drawing this 3D line from the car location to the ball location. Let's make this a target instead. So we don't need the ball anymore. And I'll even update the comment here. So the third parameter should now be the target instead of the ball. So where we call draw debug, instead of sending it the game ball, we'll send it the car to target or the target location. Let's give it the nearest boost location. Now when we resume the game, you can see that that line's being drawn to the boost instead of to the ball, which is what helps us to debug exactly what our bot is doing. Now our main game loop here, the get output function, it's getting a little bit messy for my taste. So what I'm going to do is I'm going to go through and clean this up. I'm going to try to keep this as simple as possible and move the more complicated logic to its own functions. So at the top, I'm going to keep these 4 lookups. We have all this information just in the get field info and the packet that we're given, and it'd be fine to keep referencing those instead, but these are things that we use a lot, so I think it is kind of nice to define these right here in the game loop. And then our call to get nearest boost, I'll leave that here. This will be the part of our code that looks up our target. But everything below here, I'm going to move most of this to a function that makes our card go to whatever target we get it. So why don't I update this variable name to be target. I'll call it location. They keep using the full location word, so I will too. And then I'm going to set the controller state equal to action go to. And to get our car to go somewhere, I think we need to pass in my car. Might as well give it the car location too, since we've already looked that up. And then of course we need the target location. So I'm hoping that this action go to function will just tell our car to drive to whatever target we give it. And instead of making action go to like a utility function like we have down here, I think I'm going to make this actually part of the MyBot class. So we'll have to call self.actionGoTo on it. And then all this code below it, I'm going to move to that function. I'm going to leave the debug stuff, I'm going to leave in the get output, the main game loop here. I think that's all right to leave the debug here, but you could move all this to its own function as well. There's already this draw debug. You could move this corner debug stuff. But of course, it'll need access to all the packet and info and everything you want to print out in it. So for that reason, I think it's a little more convenient to leave it here. So down below there, make sure you get your tabs right. You need to have this next function definition inside your MyBot class. And then this is the code that we want in it. But of course we need the definition too. We want the definition to look like this. Don't forget the colon. So now we have this new method on our MyBot class called ActionGoTo. And in it, we're looking up the car to target by checking the target location and subtracting the car location. We don't need this ball location stuff anymore. So then we look up the orientation just like before. I think we have all those variables available. Car direction, we have that. Car to target, we still have that. We still have all of this. This is all fine. I think that when I called it though, I wanted to set the controller state based off of what's returned by the action go to. I could just set the controller state here, but I think I do want to return this actually. So to do that, I'll need a new instance of the controller class. So my controller will be a new, it's called simple controller state. And then we can simply set all of these parameters on our controller state. And then we can return the controller so that when it returns from this function, it'll be assigned to the controller state for our class. And so by cleaning up our code here, that makes it really easy to switch what our target location is. So say we don't want to go to the nearest boost anymore. We want to say target location is the ball location. we can do that real easy right here, and we know that it's going to go to whatever target location that we give it. So let's go ahead and try this out. Go to action go to needs 3 positions as long as, but I was given 4. Okay, so what it's saying is that even though we only see 3 here, and there's only 3 in the definition here, because this is a method, it's a class function, the first parameter always needs to be self. And you'll notice it's already in the get output and the initialized agent function definitions. Self is there, and you need to do that for any function that you have that's part of a class. So now it's saying nearest boost location is not found in the console. So where am I using that still? Okay, so in our corner debug, and then also we're trying to draw a line to it as well. So we really shouldn't give it the nearest boost location, it's really the target. Target location is what we're going to print out in the corner, and then also when we're drawing our debug. Any other errors? Action display is not found. So action display, I must have moved that, huh? So yeah, so inside of our action go to, the action display is now a variable that doesn't exist. I create it here, nothing is done with it. And then up here in the get output, action display was never defined. So I'm going to turn this into a class variable. So action display, by default, set it to none. I could also do this here inside the initialize agent. I could do self.action display equals none. Your preference, I guess I'll do it inside the initialize agent. And then when we reference it, we'll need to put the self in front. So here we know we're referencing not a local variable, we're referencing a property on the class. It looks like our bot has loaded successfully now. So if we resume game, it's now going to the ball just as we told it to do. And it's also drawing the line to the ball, which is the target location. And then if we update our code to set our target location back to the nearest boost, and continue our game, you can see the behavior of our bot immediately changes. It's now going to the boosts that we wanted to grab. All right, so I'm pretty happy with where our BoostHog bot is at right now. Let's give it a shot with a bunch of them all running at once. So let's take BoostHog 3v3. Let's watch what happens. I'll stop our existing match, start a new one. So one thing you'll notice is in the lower left there, we're drawing now 6 different outputs, so they're all kind of overlapping in the lower left-hand corner there. We're also finding issues coming up when all the boosts are taken, they don't really know where to go. And if you look over in the console here, we're seeing all kinds of errors. It doesn't know how to subtract none from vector 3. And what's happening here is whenever all the boosts are taken in the game and the BoostHog doesn't know how to find the nearest boost anymore because we're only looking for the large ones, it's returning none in that function, and then we're using that value that was returned, that none, and telling our bots what to do with it, but it's hitting an error here because it can't subtract none from a vector. Okay, and I've made the console text here a little bigger so you can see it better. But if you look at this error message, it says type error unsupported operand for minus. So this means the unsupported operand, the operand is the minus, and it can't do the subtraction here for this minus sign. And it's trying to subtract a none type from a VEC3. And if you look at this error message further a little bit up, it even tells us exactly where it's happening. So it says in our bot code on line 40, inside the action go to function, this line here, the car2 target is trying to subtract the target location, which is none, from a vector 3, our car location, and that's where it's failing. So inside our code, we can go down immediately to line number 40, and we can see right here what's happening. So a really naive way to fix this would just be to if not target location, or it's a little more explicit to say if target location is none. What if we just returned out of this function? So this function is supposed to return a controller value, a simple controller state. So let's return the controller. Why don't we go ahead and just completely restart this match as well. Stop it, start the match. Looks like RLBot might even have crashed completely, so I'll go ahead and close down all of it and restart it. So we've got our bot running in, and still we're seeing errors in the console log. And it's still having problems with the none type when it can't find any of the large boosts. So let's go ahead and address this more fully and completely in the next video. If you want to play against your own bot, then back in the RLBot GUI launcher, find human here from the player options, and then just drag that down to one of the teams, set your bot on the other team, and then start match. And then once the game is launched, you'll see that only your bot is in the game playing. Go ahead and bring up the start menu and go to change team, and then select the other team. And so now I'm on the blue team, and I can play against my BoostHog bot here in Rocket League. Totally missed the ball. Got it.
So there we go. That wasn't so bad, was it? We've got our bot running, and we've already changed its behavior pretty dramatically. Thanks to the code that was already provided to us, we didn't even need to do any of our own vector math. We simply changed the target location of where our bot is driving to. But you should be feeling a lot more comfortable now with how the RLBot framework is structured, and hopefully you're starting to see all the possibilities. If you have any questions or difficulties with this part of the tutorial, please just leave a comment below, and I'll do my best to help you through it. In the next video, we'll address the bug we found when all the boosts are taken. We're also going to add some decision-making intelligence to our bot, so it's not simply going after the nearest boost every time. First, I'm going to make BoostHog go after the ball during kickoff. Then, I'm also going to keep track of how many boosts we collect, so that we can veer towards the ball when the opponent least expects it. That will give you some idea of how you can put together a more sophisticated bot, one with multiple behaviors and decision-making logic that can switch between those behaviors at the appropriate time. From that, you'll have a foundation for building your own unique AI. So when you're ready, I'll see you in the next video.